Hello, pre-calculus. New chapter, new video. We're talking about exponential functions. These are basically functions that have a base that's constant and a variable for its exponent. You're going to see how this ties into inverses when we start dealing with logarithmic functions, but for now, let's just talk about how to graph these things. So as you can see, I'm asking you to indicate a lot. Horizontal asymptotes, those are a thing. They're back. Domain and range of a function, woohoo. And then a table of 5 values. So maybe a good place to start would be the table of 5 values. This is where we just create a box here and say x comma y. Now the good news is you can use a pretty standard -2 to 2 window. At least on tonight's assignment. So for the most part, these are going to be the points of interest for us. If I type that into the table function of my calculator, don't forget parentheses where applicable. They are important. All right, so when I go to the table on this, -2 corresponds to 3.75. -1, 3.5. 0, 3. 1, 2, 2, 0. All right, plot those points. So here's my y-axis, here's my x-axis. Left 2 up 1, 2, 3.75. Left 1 up 3.5. 0 up 3. 1 up 2. 2 up 0. You know, and I'm curious about what else is going on here. If I plug in 3, I get -4. Ooh. What happens if I plug in -3? Go all the way back to -3. 3.875. That's just getting closer and closer to 4. What if I go to the table set and plug in -100? What do I get? 4? Oh. It levels out at 4 as you keep going left. Horizontal asymptotes. Okay. We got our table of 5 values. We've got a bunch of points. We've got a leveling off point of 4. It's never going to go above that. So we're getting so close. And then, oh no, it dropped off the map. And it just keeps going farther south. So there is a horizontal asymptote. I'll just abbreviate it HA. At y equals, it's a horizontal line, which is what we indicate with y equals 1, 2, 3, 4. Got it. Got that. Got this. I didn't say anything about vertical asymptotes because there's technically none. If I plugged in any number at all, I'm never going to have a vertical dashed line. Every number, x, has a y value on this curve. So we got the graph. We got the table of 5 values. We've got the horizontal asymptotes. Now, what would the domain and range be of this thing? Well, if you recall from last chapter, the domain is where all the x's live. Since there's no vertical asymptotes, and there's no holes in the graph, and there's no spot where it just basically stops going, it's not leveling off at any point here. If I plugged in 1 billion, I'm going to get a number. In fact, let me do that right now. 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. If I go to my table, well, I don't think my calculator can handle that large of a number because I just took -2 to the billionth power. I got an overflow error at this point. So what we're going to do is say, that's a really small, that's a negative number that's way farther down there. So -infinity to infinity is my domain. And for the most part, my domains for all my exponential functions will be -infinity to infinity. My range, on the other hand, is a different story. all the x values are accounted for, but the y values just stop once you get to 4. Okay, so it's never going to go above 4. So negative infinity, all the way up to 4, it hits a roadblock. We got to stop completely. Does it ever actually equal 4? No, it's getting infinitely closer to it, but it's never going to actually yield a y value of 4. So we put a parenthesis to say, don't include me. And there it is. So take note of one thing. I added 4 to the exponential function, and my horizontal asymptote turns out to be 4. I have a negative in front of my exponential term, and it seems to have been flipped over this asymptote. I think that's a pattern that's going to hold. Let's check out number 2. All right, so we're dealing with bigger numbers here. That usually spells trouble, but let's not panic just yet. I'm still going to try -1, -2, 0, 1, 2. I'm just going to check out what my table of values gives me. Maybe not start at -1 billion this time. Oh, -2 is -9.7 repeating. That's 7/9. -1 is -9 1/3. 0 gives me -8. 1 gives me something more reasonable, -4. And then 2 gives me 8. Wow. So I think I'm going to skip count by 2s here so that I'm not just operating mostly off the 7 by 7 by -7 by -7 grid. So I'm going to go, every one here represents 2. And every one here represents, well, you know, I'm just going to make the ones on the x-axis represent 1. Okay, so 0, 2, 4, 6, 8. That's a point. 1, 2, 4. 2, 2, 4, 6, 8. And then it seems to be leveling off. Yeah, if I plug in a really small number like -1,000, I get -10. So -10 is going to be my horizontal asymptote. 2, 4, 6, 8, 10. These 2 points plotted will get me really close to that new axis, but not quite. It just levels out from here and then shoots up super quick. Just pretend like it's going through that point. Notice that these numbers jumped up super quickly. That 2 in front is acting as a stretching agent. Remember stretching from the previous chapter? Or was it the chapter before that? I think it was the chapter before that, the graphing sense chapter. Yeah. So we're still dealing with a shift down, which is like our asymptote. A whole number out front stretches things. The domain is still going to be from -infinity to infinity. The range will never go below -10. So -10 is the starting point, the basement value for my range. Not including it, it's never going to actually equal -10. And then it is limitless. It goes up forever. All right, why don't you guys try number 3 on your own? Pause the video. All right, let's see how successful you were. Before we do anything, I'm just going to say right off the bat, we have a horizontal asymptote at 3. We got a negative number out front, which means we are going to be pushed down below that y equals 3. So you know what? I know my domain. My domain, all the x values are going to work. It's going to be -infinity to infinity. My range, My range is going to peak out at 3. It's never going to equal 3, though. Wait a second. Strike that. Reverse it. It will peak at 3. All right, so what does my table of values tell me? I'm just going to go -2, -1, 0, 1, 2. We don't want to start at -1,000. All right, this is like 2.994. This is 2.97. Okay. I hear you. 2.85. 2.25. That gives me -3/4 or -0.75. So what's happening here? Well, we are really close to our asymptote right off the bat. So y-axis, x-axis, we are right there, ever so close to 3. And then it's getting a little bit further away, and then it jumps down a little bit more at 2. Well, basically the 5 right here is going to create huge numbers. This is going to try to dampen it a little bit. Remember, the 0.15 is sort of like anything below 1 is going to be like a shrinking agent, one that makes it a wider function. But it just can't overcome the 5 right now. The 5 is too big of a number. Yeah, because if I plugged in 3, it would already be down to -15.75. See? All right, guys. I think you get the idea. I just wanted to highlight one more situation, one in which the base was a fraction. So the question becomes, is the fraction going to mess with our horizontal asymptote? It seems like there's nothing added to or subtracted from here. So our question is y going to still equal 0? Second question, are we still going to have -infinity to infinity for our domain? I mean, it's an exponential function, and they've all been all real so far. Is this one going to be the same? And then our range value. Our range value was either the ceiling was either 0 or the basement was 0. Well, there's a positive in front, so we should be able to say that's the basement. Doesn't go any lower than that. These are the questions I have about this one. The table of values will hopefully lead us to the right answer. So we're going to plot this. All right. I'm going to go backwards this time. 2 gives us 1/9. That's really close to the x-axis. 1 gives us 1/3. That's not quite as close, but still pretty close. 0, 1. Oh yeah, anything to the 0 power equals 1. -1 is 3. -2 is, 9. Whoa. So what's going on here? Let's plug in some numbers in the future a little bit farther. What if we plugged in 20? Oh, 3 times 10 to the -10. That's 0.000000003. Maybe there's another O in there. Yeah, the x-axis is our horizontal asymptote. Bingo! Yes! It stands to reason that the x's will always be okay. Oh, it's been flipped. It used to be like this, but it's been flipped horizontally now. Sorry, I didn't write what the -2 was. It was 9. That doesn't seem right at all, does it? That should be a 3. Sorry for the confusion. But bottom line is, yes, the domain is still negative infinity to infinity. Yes, the range bottoms out at 0 and goes all the way to positive infinity. So you can continue to use those little breadcrumbs by just looking at the equation, even if there's a fraction inside there. Here's actually what's happening. 1/3 is the same as 3 to the negative 1 power. So 1/3 to the x is the same as 3 to the negative 1 to the x, which if you multiply the powers, because that's the rule, a negative x flips it horizontally, just like root negative x flipped that horizontally. What were some of the other examples? I can't think of the other examples right now. That means it's a good place to stop the video. So we got 4.1 out of the way, exponential functions, the graphs. Yeah. Man, I'm a bit rusty here, aren't I? Got to get back into the rhythms of making videos. That's all I got.